Hi, good afternoon. This is Mrs. Hasner, and today we're going to review Punnett Squares, and we're going to go over different color eyes. So brown eyes is dominant, so it's represented by a capital B. Okay, recessive is green eyes, so it has two lowercase g's. We're going to say the lowercase g represents green eyes, and blue eyes is represented by two lowercase b's. Okay, so this is what we know, the facts. Dad has a genotype of dominant B and recessive B. And mom has a genotype of recessive B, recessive B. Okay? And we're trying to figure out what color are the father's eyes, what color are the mother's eyes, and then we're going to try and figure out the percentages of chances of having brown eyes, their offspring, or blue eyes, or green eyes. Okay, so let's start with this. So we'll put the dad's genotype here. Dominant B, recessive B. And then mom's genotype, let's put it here. Recessive B, recessive B. Okay? So based on just looking at their genotype, capital B is dominant, so it's dominant for brown eyes. So dad has brown eyes, okay? He's a carrier for blue eyes. And mom has two recessive lowercase b's, which is for blue eyes. So mom has blue eyes. Dad has brown, mom has blue. Okay, so now we're gonna see if we put these together, what the outcome will be. So dominant B and recessive B. And when you put these together, usually the dominant trait goes in front, even though it looks like you should have lowercase b, capital B, but you reverse it. So that's why it's written this way. And then let's put the recessive B together. And dominant B, recessive B, recessive B, recessive B. Okay, so we know that the dad's eyes are brown, and we know his genotype, and we know that the mom's eyes are blue, the phenotype, right? And her genotype is recessive B, recessive B. So based on this, if the question was, what are the chances of their offspring having brown eyes? So look in each box and see which ones have a dominant trait. So we have 1, 2. 2 out of 4 would have brown eyes. That's the possibility. So 50% chance of having brown eyes for their offspring, and 50% chance of having what? Blue eyes. Okay? And then if they asked you a question, what are their chances of having offspring with green eyes? Well, there's no G's in here, no recessive G's. So they would have a 0% chance of having green eyes for their offspring, okay? And then if they asked you how many are carrier for blue eyes, it would be 100% because each box contains a recessive B. All right, we're going to go over one more. And this one is for hair color, okay? So mom's phenotype, she has brown hair, that's her phenotype. Dad's phenotype is red, for red hair. And mom's genotype is dominant B, recessive R. And dad's genotype is recessive R, recessive R. So in other words, even though mom has brown hair, the lowercase r is representing red hair, okay, two recessives. And then the capital or dominant is representing brown hair, okay? All right, so we know mom's genotype and we know dad's, so let's just look at it. If you didn't have the picture and you just had their genotypes, you could tell that mom had brown hair because she's a carrier for red hair. And dominant is stronger, so she's going to have brown hair. And dad's genotype, the two R's, the lowercase r's, are recessive, and them combined means that dad has red hair. So anyways, we're going to put the genotypes on the Punnett Square. So you have mom's dominant for brown hair, recessive for red hair, and you have dad who is recessive twice for red hair because he has red hair. Okay, so then put these two together. Don't put the little r first, put the dominant. So dominant, recessive, and then put these two together. Little r, okay? Little r and capital B, so it would be dominant B for brown hair, recessive R for red hair. And then put these two together, okay? So if they ask you what are the chances of the offspring having red hair, it would be 2 out of 4. So it would be 50% chance that the offspring would have red hair. And what are the chances of their offspring having brown hair? It would be 50% again. It's 2 out of 4 because you have 2 with the dominant B for brown. And then and sometimes they ask you questions like this just to make sure you understand. They'll say, okay, what are the chances of their offspring having blonde hair? Okay, neither one has any of the alleles for blonde hair. Okay? And I have one more. We'll just go over and review. And then you can make up your own Punnett Square. You know, whether it's hair or eyes or however you want to do it. Okay, so the father has dominant capital B for dad's hair color, which is brown, and he has dominant B for brown hair. So he has 2 dominant for brown hair. Mom has 2 lowercase, which is recessive for red hair. Okay, so if they ask you what color is dad's hair, you would know dad's hair is brown based off of the genotype. Okay, and you would know that mom's hair is red based off the genotype. And the phenotype is that mom has red hair, the red hair, and the phenotype is the brown hair for dad. Okay, so now you have to put it into the Punnett Square. So you have dad's genotype and mom's genotype, and you put them together. Okay. All right, so what color hair does the father have? We already went over that. He has brown, and mom has red. And what percent of the offspring have a chance of having brown hair? 1, 2, 3, 4. 4 out of 4, so 100%. If you only have 4 boxes, remember each one is worth 25%. It's a way of thinking of it. So you have a dominant for each box, so that's 25, 50, 75, 100% chance. Okay, and what percent of the offspring have a chance of having red hair? So that again would be, I'm sorry, not again, but the chance of having red hair would be 0% chance. But if they asked you, what is the, how many of the offspring, or what percent of the offspring would be a carrier for red hair, you would say 100% because each one has a lowercase r, which is recessive for red hair. All right, thank you.